Let us see one more problem on interpolation. In this problem, they have given the values of x and y. See, these are the values of x. 60, 70, 80, and 90. These are the values of x which has to be taken in the x column in the table. And these are the values of y, that is y naught here. This will be your y1 and so on. These are the values of y which has to be taken in y column. Now they are asking us to find f of 38 and f of 85 using a suitable interpolation formula. Why they are asking using suitable interpolation formula? Because the application of formula depends on the value of x. Since this value of x, that is 38, falls in the first half, we need to use forward interpolation formula here to find f of 38. And since this 85 falls in the second half of the data, we need to use is backward interpolation formula. Let us collect the values of x in the x column, that is here, and the values of y in the y column here. Now here they are asking us to find f of 38 first. Since this 38, the value of x 38 falls in the first half, we need to use Newton's forward interpolation formula to find this value. And then to find f of 85, since this value of x, that is 85, falls in the second half of the data, we need to use Newton's backward interpolation formula. So in the same problem, they are asking us to apply both the formulae. So that's why we have not denoted any delta or nabla here. Just we have taken it as a first difference, second difference, third difference. That is, in any question, if you have to use both the formulae, don't denote any nabla or delta. Just take first difference, second difference, and so on. Finding these entries will be same as the previous tables. That is 204 minus 185 will give 20, and so on. In this last column we have got all the zeros, so we need to stop here. To find f of 38 using a forward interpolation formula, these entries are very important. That is this is y naught, delta y naught, delta square y naught, delta cube y naught. And when you are using Newton's backward interpolation formula to find f of 85, you need to use these lower entries. In these entries, this is your yn nabla yn nabla square yn nabla cube yn. See, here we are going to find f of 38 using Newton's power interpolation formula, which is here. So as I said, we require y naught, delta y naught, and so on, which we have collected here from the table. And let us find r first. What is the value of x? The value of x is here, that is 38. In the place of x, put 38. And where is x naught? X naught is the first value of x in the table, which is 40. And h, the difference between any two consecutive values of x, is 10. If you simplify using your calculator, you will get minus 0.2. If you put the value of r and the delta values in the formula, your formula will give this. If you simplify using your scientific calculator, you will get the answer as 180.24. You all can try this. So f of 38 is equal to this. Now let us find f of 85 using a backward interpolation formula. As we require, we collect the values of xn, yn, nabla square, yn and all, which has to be substituted in the formula here. Let us find r now. The value of x is 85. Value of xn is 90. As we have collected here, xn is 90. And if you simplify using your scientific calculator, you'll get the answer as minus 0.5. Substitute the values of r and all other values in the formula. You'll get the answer of f of 85 as 289.75. Let's see one more problem. So in this problem, the function is sine function. Sine of 45 degree is 0.7071, and all they have given. In this given data, what is the value of x, what are the values of x, and what are the values of y. So these 45 degree, 50 degree, and 55, 60, all these you can take it as x values. See, here we have taken as x values here, and the respective functional values, that is 0.7071 here, and this value, and this value you can take in the y column here. Okay, now what they are asking in the question, they are asking us to find a sine 57. Now the question is which formula we need to use. Since this 57 falls in the second half, see here, in the end of x values, so which formula is appropriate here? Newton's backward interpolation formula. So we need to use Newton's backward interpolation formula. So that's why in the table we are taking nabla y, nabla square y, nabla cube y, and the process of finding these entries remains same. That is this entry 0.7660 minus 0.7071 and so on. So here is the formula for Newton's backward interpolation formula. Now in the table, which are the important entries? See, these are the important entries which are very useful in the formula. Let us collect all these entries and list. Now let us find out the value of r. The value of r will be here. In the place of x we have put 57. Value of xn will be 60 in the table, and difference between any two consecutive values is 5. Collect the values from the table here and put in the backward interpolation formula and simplify. You get the answer for sine 50 degree 50 sorry sine 57 degree as 0.8387.